Okay, question 7. Quite small questions. So, you're thinking this could be quite good, but does look complicated, doesn't it? So I think this is where you've got a semi-technical question that's broken up quite nicely to help you along. Okay. So the first bit, integrate this term. Now, this is a banker, okay? I think when it comes to your further calculus, you're given the equations at the front, get that learned. Okay, that's something that's really worth looking at. Okay, they can't ask you it in so many different ways because it's a new skill and the formula is a formula, so it's quite nice. Right? So you look at the front of your paper, you'll see the kind of general equation for it. I might just take a wee crop of that for you just to show you. So the minute you see a kind of complicated bit of calculus, you should be thinking further calculus. Okay. And certainly if you're integrating or differentiating trig, that should be coming to your mind as well. So we'll just put this on the side just to show you. Probably should have just done this at the beginning, but okay, there we go. So you can see here when you integrate, you're going to divide by the derivative of the bracket. That's what that's saying, really. Okay, and also, it's telling you what happens when you integrate sine and cos. I always just, remember if I differentiate sine, I get cos. If I differentiate cos, I get negative sine and negative cos, and that just repeats over and over. So that's your differentiation, and that's your integration. Okay, so that same pattern just keeps going on and on and on forever and ever. Okay, so if you remember that, which you can derive from this, you don't really have to stress about what sine and cos become. All this is really telling you is that when you integrate, you divide by the differential, and when you differentiate, you multiply by the differential. Okay, so here, I would write it like this. I'd say, okay, well, I know cos, if I integrate cos, I'm going to get sine. So I've got sine 2x, because the 2x stays the same. 1 is obviously going to become x. We should know that from before. And don't forget your plus c. And the only bit that's different is that I need to know that this 3 stays where it is, and I'm dividing by the new differential. Okay, dividing by that 2. So for 2 marks, quite nice. Quite nice. Okay, good. Part B is a bit of a mean one, I think. So it's saying show that this, that your original integral could be written as this. So, okay, I'll be saying then 3 cos 2x plus 1. How can I rewrite that? Now, if you've got your cos 2x, you're thinking, well, I need to go to the front of a sheet and see what other identities I've got, which I could potentially substitute in. So again, I will just copy these down over here. Okay, there we go. So we've got 3 potential options. And if you look at the question, we've got 2 squared, sine and cos. So we should be thinking that this one is going to yield something similar to what we're after. So I'll put in my cos squared x, take away sine squared x plus 1. So that gives me 3 cos squared x, take away 3 sine squared x plus 1. And you thought that must be equal to the right hand side. Oh, no. No, I've got 4 there and 2 there. I'm really, really close. I've got an extra cos squared x. I've got an extra plus cos squared x and plus sine squared x. That's a bit weird. And I don't have this 1. Is there any way I can sub out the 1 rearranging that? Not quite. And this is where they're drawn on your National 5 skills, okay? So you need to remember, this will be given to you, that tan x is sine x over cos x. And also that cos squared x plus sine squared x is equal to 1. So that 1, I can actually rewrite that then as, so I'll say I've got 3 cos squared x, take away 3 sine squared x plus, and the 1 becomes sine squared x plus cos squared x. And that's why we've got 4 cos squared x's, and I've got negative 2 sine squared x's. Okay. So a little bit mean. I think sometimes those rearranges can be a little bit harsh. And just say that now equals the right hand side as well. So they can be a wee bit harsh, I think. But look, you are given these, and all you have to remember is this from that 5, and then it's a bit of rearranging. I think you would get a mark just for putting this in. So getting up to here, which isn't a big leap, 1 mark out of 2. not awful, but that's something that people forget about. Okay, nice one. And question C, so a little bit of thinking now. Hence or otherwise integrate this function. So the hence means we're using the bit from above. So I'll be saying, okay, how do you get from this bit to this bit? What's the difference? So I've got a 4 cos squared. Now it's -2. Okay, and then I've got a -2 sine squared, and now it's sine squared. So it looks like they've divided by -2, or times by -1/2. Okay, so my function has been multiplied by -1/2 in that case. Okay, so the original function, I'll just write that. I'd maybe just say that the integral of sine squared x take away 2 cos squared x dx, that is then going to be equal to the integral of my 3 cos 2x plus 1 dx multiplied by, and it's -1/2. Okay, because this function is the same as this one, so we have already integrated that, we've done the heavy lifting there, and that function is the same as this, so to do this function, I need to divide by -2 or times by -1/2. Okay, so you're trying to spot that relationship between these two functions. And then at that point, you say, okay, well, I'm going to integrate. That'll be -3/2 cos 2x take away 1/2 dx. And then we're just integrating the exact same way we did. And actually, really, you could kind of just go straight to the end and multiply by -2. But anyway, I'll show you this. So cos becomes, well, this time it's negative cos, isn't it? So negative cos becomes negative sine. So I've got negative sine 2x. The -1/2 is -1/2 x and plus c. So you're seeing the relationship there. It's just timesing it all by -1/2. And then this one, the 3/2 would stay where it is. But instead of dividing by 2, I'm going to divide by 4 because I have to multiply through by my differential. So you see that each term has just been multiplied by -1/2. Simple as that. But just to kind of show you the pattern, all right? So I think you could have been lazy and just gone straight to here and times that by -1/2. But I just thought it would show all the working. Okay, so slightly tricky maybe to spot. I think that was a bit, because they've modelled it left and right and things. But yeah, what's your relationship between the thing you have integrated and this new thing? Okay, so yeah, they were just looking for this -1/2, and for you to spot that you're not integrating this, you're integrating this. Okay, so yeah, I hope that's helpful.